Hi everyone, today we're going to be talking about integration by partial fractions. Oops, that's not the right pen. What a good start. So if I had something like 5x take 10 over x squared minus 3x minus 4. Now, how would I go about taking the integral of this? I might decide to use substitution, but I note that the derivative of the denominator would be 2x minus 3. That is not an easy multiple of what I have in the numerator. So substitution is going to be a little bit, it's going to give me a dead end, really. So what we need to do is this technique called partial fractions, which basically means we try to rewrite the algebraic expression as the sum of two fractions. Now let me show you what I mean. If we have an aside over here, and this will actually be where the majority of our time is spent, 5x minus 10 over. Now I'm going to see if I can factor this quadratic, and I think I can, because the numbers negative 4 and positive 1 would add to give the middle value, and they would multiply to give this. So that is factored as x minus 4, x plus 1. Now, I should be able to write this as two separate fractions with different numbers on top. Now, if only I knew those two numbers. And just like, going the other way, in algebra, plenty of times we would have started with something like this, and we would have multiplied the denominators to get a common denominator, and we would have then added the terms in the numerator to simplify. So we're just going in reverse here. And let's see how we would do this. Well, if I were to add these, I'd have to do the whole common denominator, and I would have a multiplied by x plus 1 plus b times x minus 4. So this would be ax plus a plus bx minus 4b, still over the denominator. And now grouping together, that would be a plus b times x, so ax plus bx is a and b added together. Now then we would have the constant a minus 4b together, still over this x minus 4, x plus 1. Now what was the left hand side? What did it start with? It was 5x take 10 over this denominator of x minus 4, x plus 1. So we have a correspondence here between the numerators. In fact, we have a correspondence here between the number 5 and the terms a plus b. We have a correspondence, I'll go blue for this one, negative 10 would be a minus 4b. This is going to give me a way to solve for the unknown a's and b's. So I have a plus b equals 5, let's call that equation 1. A minus 4b equals negative 10, let's call that equation 2. I think if I have equation 1 and I subtract equation 2, a will disappear, b take negative 4b is 5b, and 5 take negative 10 is 15, therefore b equals 3. And from, it's probably simpler to consider 1. A would equal, something plus 3 equals 5. A would equal 2. We've got it. So A is 2. This number up here, that's a 2. I'm going to rewrite my integral as 2 over x minus 4 added 2. Now what did we say b was? B was 3. This is 3 over x plus 1 dx. So, well, the integral of an expression which is a constant divided by something in x is the constant will be there, and it's the natural logarithm of x take 4. Then the next term will be a constant of 3 by the natural logarithm of x plus 1 plus a constant of integration. So there's my integral. My integral was done in 3 steps, but the preparation to get from step 1 to step 2 took all of this work over here. And this is the stuff over here we refer to as partial fractions. We're decomposing this rational expression, which is what we were given to start with, into 2 fractions. Each of them is a part of the original. That's why it's called partial fractions. Notice that it worked here because my numerator was a linear term and my denominator was a quadratic term. And generally speaking, that's what we need in order for this to work. The numerator has to be of a lower degree than the denominator. So it could be a quadratic in the numerator and a cubic in the denominator. That would work. There's another thing that I must mention about this as well. So I don't want to keep going too long because that's the gist of it right there. But if I had an expression that was, well, I don't know, I'll just make something up, x squared minus 4x plus 3, and let's say the denominator was a cubic, and once factored it was x plus 1 by x plus 1 by x minus 2. So when I decompose this one, you would expect there to be 3 terms because there were 3 linear factors in the denominator, and that's true. So you would have an x minus 2 over in that point. You'd have an x plus 1 in this point. Now you might be tempted to call this one x plus 1, but the trouble with that is it's a repeated term and it's not going to give a unique answer for the numerators a, b and c. So what we have to do in this case, if there's a repeated term in the denominator, we have to have it appear first at the power of 2 and the next time just as a linear term. Then you would go ahead and solve in the usual way, and that will give you your unique decomposition with numbers, unique values for a, b and c. A, b and c will be constants then. If you forget about the repeated term and the power thing, you won't end up getting a decomposition and you won't get too far. So that's a tricky one to watch out for, but the majority of them will be ones like this, where you have 2 unique linear factors, and so they just appear once each with a different constant a and b, or c if there's a third unique one, and you do your decomposition like this. A little bit of simultaneous solutions going on down here, so nothing more than algebra, and it makes our integral child's play. The integration step from here to here couldn't have been easier. Okay, that's enough for now. I will let you digest this and then try a few of those questions from the text. Thanks for watching.